Good day, I'm Kathleen King Mansueto and I'm gonna show you facing and turning using Lathe Simulation app. But first, let's get to know the 5 major parts of the lathe machine. First is the headstock. It is located at the left end of the machine. It contains spindle speed that provides the rotational power for the lathe's operation. Second is the tailstock, located at the higher end of the lathe. It is usually used to apply support to the longitudinal rotary axis of a workpiece being machined. It can be adjusted to set the length of a work. Next is the carriage, located between the headstock and tailstock. It serves as the purpose of supporting, guiding, and feeding the tool against the job during operation. It can also be moved sideways and also crossways. Next is the machine bed. It provides a foundation for the ways, which in turn carry the carriage, tailstock, and other components such as steady rest and carriage stops. Lastly is the feed mechanism. It enables automatic feeding for the tool longitudinally and transversely as needed. Now let's proceed to turning and facing operation. I use 100 mm length and 30 diameter of mild steel, and I will be using number 5 cutting tool for the turning operation. Here I use 40 as cutting speed because mild steel range from 30 to 45. Now the spindle speed of 28 diameter is 454.7. Let's not forget to turn on the machine. Since there is no exact 454 RPM, we will set it to 500 since it's the nearest value. We will move our carriage near to the workpiece to start the turning operation. I also turn on the coolant system to cool down the workpiece during turning operation. After that, we will activate the tool-post handwheel and carriage handwheel to make the calibration. Let us set the diameter to 2 mm to start the first 2 mm turning operation. We can click this button so that we can easily do the turning operation to the opposite side. Then we will turn off the chuck, then check the vernier caliper to see the new measurements of our workpiece. So here we have 100 mm length and 28 mm diameter workpiece. Now let's proceed to the 15 mm diameter and 20 mm length. Let us change the spindle speed for the 15 mm diameter. I used the same cutting speed which is 40, so our RPM is 848.72. Since there is no exact 848.72 RPM, we will be using 800 RPM because it is the nearest value. Here we need to get 13 mm diameter because 28 diameter minus 13 is 15 diameter. We should be careful not to surpass 20 mm length. Now let us check the vernier caliper to see the new result. Now we have 80 mm length and 15 mm diameter. Now let us proceed to the 20 mm diameter. I am using 630 RPM here. Since our spindle speed should be 636.54 RPM and there is no exact value, we'll go to the nearest number. I will add another 20 mm length longitudinal to have a total length of 40 mm. I will do turning at 8 mm because 28 mm diameter minus 8 turning is equals to 20 mm diameter. We should be careful not to exceed 40 mm length. Now let us see the result of our workpiece. We have 80 minus 20 equals to 60 mm length and the new diameter is 20 mm. Now let's proceed to the 25 mm diameter. The spindle speed for 25 mm diameter is 509.23 RPM. And since there is no exact value, we will use 500 RPM. I will add 20 mm length longitudinal and will not make any calibration. The total length will be 60 mm and for the cross speed, I will only make 30 mm turning to achieve 25 mm diameter. Always remember not to exceed the 60 mm length. Now let's check the vernier caliper to see the result. The new measurement of our workpiece is 40 mm length from 100 mm minus 60 mm and the new diameter is 25 mm. Now we will do the same process when we do turning operation. We will change the workpiece by clicking the lower left button to change its position. We will do the facing operation with 4 mm length to the total of 20 mm length. To achieve this, we have to subtract 20 mm length from 100 mm length. Now we are done with our 20 mm facing operation. Now we will check the vernier caliper to see the final result. We have here the 20 mm length and 20 mm diameter. We have achieved the final output of our workpiece. Thank you.